In this video, we're going to talk about the ACT question topic geometry and include the topics of sine, cosine, and tangent. These are the three main trigonometry ratios that you may encounter on the ACT. And we're going to start by talking about sine. And when we're talking about sine, we are usually talking about a right triangle. So we have a right angle, and sine is the ratio of the side opposite whatever angle you're talking about and the hypotenuse. So if we're looking at a picture of a right triangle here, we see x is the angle that we're referring to, and we have the opposite side length opposite that angle x, and then the hypotenuse. And just as a reminder, the hypotenuse is always across from the right angle. So we always need to make sure that we're talking about the correct side lengths of the triangle, and we have the hypotenuse here. Now the opposite side length is always relative to whatever angle we're talking about. So in this case, like we said, the side length that's opposite this x angle is the one we've labeled opposite. But we can have another triangle, in the case here in the bottom right hand side, where x is our upper triangle that we have labeled, and the opposite side length is different from the one we had labeled previously, but it's all relative to whichever angle we're talking about. So sine is opposite over hypotenuse. Next, we'll look at cosine. And with cosine, again, we're talking about a trigonometric function in a right triangle where we're looking at the relationship of the adjacent side length relative to the hypotenuse. So here is our picture here. If we have the angle labeled x, we have the adjacent side length, the one right next to it, and then of course we have our hypotenuse again opposite the right angle. Just as we discussed with sine, with the opposite angle, our adjacent angle is always relative to whatever angle we're concerned with. So in this case here with this triangle, if x is labeled as the angle we have shown, our adjacent side length becomes a different one than we showed right over here on the left-hand side. So it's always relative to that angle. Our third trigonometric function that we're going to look at is tangent. The tangent of an angle, again in a right triangle, is equal to the side opposite the angle that we're talking about divided by the side adjacent to the angle. So tangent is opposite over adjacent. And again, here is our picture. If we're talking about the angle labeled x, we have our side length opposite and then the side length adjacent. Again, if we change up which angle we're talking about, we're actually going to flip our opposite and adjacent. Different angles, different sides. Tangent has to do with opposite and adjacent. Now you may be familiar with this acronym that we can use to remember our opposites and adjacents and relative to each of the three trig functions we have here. SOHCAHTOA, where we get from that the first letters. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you use something like this to help you remember, that is great. Or you may just remember what the trig functions are. Remembering the definitions of each of these trig identities is important. The next thing that we need to do is how to apply. We're going to do that with a little bit of practice here. Also, make sure that you're familiar with how to use these trig functions on your calculator. Both if you're given side lengths, how to find the angle measures. We're going to use our inverse sine function or cosine or tangent function, but it's the inverse trig function that we'll use. If we're given an angle measure, we're going to just plug in the straight trig function of that angle measure. Make sure if you're working in degrees or radians, have all that set on your calculator correctly and know how to use that. And we'll get some practice with some of the examples. But now let's take a look at one such example. Pause the video here, work this problem, and come back and we'll check it together. The question asked, which expression gives the measure of angle A? So we are looking for an angle measure, and we have side lengths drawn out. So when we're looking for angle A, there's several different ways actually we could find the measure of angle A using our three different trig functions. What we have to do though with ACT, given that it is a multiple choice, we've got to look at the ones they've given us and determine which one of these is correct. Because like I said, there is more than one way to find the measure of angle A with a trig function here. So when we look through our answer choices A through E, we're going to see that either we're going to be using the inverse cosine function or the inverse sine function. So if we think about cosine first, by definition, we know that cosine is adjacent over hypotenuse. And for angle A, our adjacent side length is B, and our hypotenuse is C. So that would be B over C. We don't have that for either A or B, which are the cosine inverse options. So we know A and B is out. Remember, sine of A is going to be opposite over hypotenuse, and opposite of angle A is side length A over our hypotenuse C. So that's going to be A over C. And since we're looking for the angle measure, we have to use the inverse sign. It will be sine inverse of that A over C, which gives us answer choice C. We didn't have to plug in any actual values or even use our calculator, but we did need to know the definition of sine to help us get this answer.